So now we'll be applying the same equations of motion to free fall. So free fall by definition means that we are talking about any object which is falling under the effect of just one force, which is its own weight, right? So we don't talk about air resistance or upthrust or any of those things. So the object is falling, right? It's freely falling and the only thing which is the only force which is acting on it is its own weight. So when the only force acting on it is its own weight, so we also know that correspondingly the acceleration it would be experiencing would be the acceleration equal to the acceleration due to gravity, and the value for this is 9.81 meters per second square. So what this means is, for example, if this is level ground right here, and if this ball is projected, for example, if this is thrown upwards, so it would go all the way up, and by the way it would fall straight back down, because remember that the condition for using the equations of motion is that the motion must be straight line. But just to show the return journey, I'm going to make it slightly curved at the top, just to show that this is the return journey. And throughout this entire time, we know that the acceleration will be equal to the acceleration due to gravity. But now I also want to talk about one thing other than this, which is that remember that acceleration, displacement, velocity, either initial or final, are all vector quantities here. So now you could have this, that for example from here it was thrown upwards and then the acceleration is directed downwards. So we need to establish what is called a sign convention. And what a sign convention really is that we specify some sort of a direction, that we will say that we take vectors in one direction to be opposite and take vectors in another direction, in the opposite direction, to be negative. So for example, in this case, what I can say is I can say that vectors directed upwards are positive and vectors directed downwards are negative. And I can also say the reverse. It really doesn't make any difference. It's totally up to you. You can choose a sign convention, whatever you want, and then calculate the answers accordingly, right? So for example, from here, if the object was projected upwards with some initial velocity, so I would take u as a positive value, right? Because this is directed upwards. And since acceleration is directed downwards, I'm going to take this as negative 9.81. So having understood this, now let's go on to the questions. So this is going to be a full, very comprehensive question. This is the question prompt, and we'll be adding different parts to this as we go along. So a ball is projected upwards from the ground. So it's projected upwards at a speed of 20 meters per second. Right, so it's thrown upwards with the speed of 20. Actually, let me make this diagram a bit larger just in case I need to mark something later. So this is 20, the initial velocity with which it's projected. So u is 20. So ignoring air resistance, because again, if we don't ignore air resistance, we know that the acceleration will not be constant anymore. Right? This is a concept that follows from terminal velocity. So then if the acceleration is not constant, we cannot use the equations of motion. So the first part says that you have to calculate the velocity of the ball after 0.8 seconds. So what's going to be the velocity of the ball? So unlike the questions that we've seen earlier, where the acceleration used to be spelled out very clearly, whatever that value was, since it's now traveling in air, you know that the acceleration is going to be equal to g, 9.81, downwards. And since I already can see here one vector is directed upwards, one vector is directed downwards, let's just specify a sign convention which we'll use throughout this entire question then, which is that I'll take vectors upwards as positive and vectors downwards as negative. So now let's try to understand what I have here. So I know my u is 20, and since it's upwards, it's going to be positive 20. The acceleration is acceleration due to gravity. Since it's downwards, it's going to be negative 9.81. And I want to find the velocity v of the ball after 0.8 seconds. So my time is 0.8 and I need to find v. So if I find v here, v equals u plus at. So this answer, so u is 20, a is negative 9.81, and the time is 0.8. So this value for v turns out to be 12 meters per second. So at 12 meters per second, if I also think about the journey as a whole, this is positive 12 basically. So it means that it's at some point like this. So the speed is lesser than what it was initially, which is what we also know from real life, that an object thrown upwards will basically become slower due to its weight. But at some early position, it's still traveling upwards, but the speed has reduced from what it was initially, right? So I can say that because this is positive 12, it is still traveling upwards. So positive sign of v shows that it's moving up. Let's add another part to this question. Part B is, so in part B, we have to find the height of the ball. Obviously, height above the ground is what I meant here. So height of the ball at 1.5 seconds, right? So if you want to find the height of the ball, again, we know that u is positive 20. So let's just write this here. U is still positive 20. A is still negative 9.8 because it's downwards. And we want to find the height at time t equals to 1.5 seconds, and I want to find s. So which equation of motion are we going to use this time out? So we are going to use s equals to ut plus half at square, because that's the only equation of motion which involves these variables. So u is 20 times 1.5 plus half negative 9.8, and the time is 1.5 squared. So using this, the answer for displacement you'll get is 18.96, so 19 meters, correct to 2SF. Now this displacement is also positive. So this means that this is above the ground, right? Because we took vectors above to be positive. So positive sign of S shows that this is above the ground. And right now here, this seems pretty obvious, because if it's thrown from the ground, then it goes all the way up and then it comes all the way down. It never actually goes below the ground. But you could have a different example where it goes below the ground. And in that case, the displacement would be negative. But since here it's positive, it means that it is above the ground. So all of these answers will make sense according to your sign convention. Let's add a part C, which is the velocity of the ball after 3 seconds. So again, the initial two variables are the same. U is still positive 20, A is still negative 9.81. Only now the time is t equals to 3, and we want to find the final velocity, which is really v. So we use v equals to u plus at again. So the answer that we get this time is negative 9.43. So negative 9.4, correct to 2SF. And now this negative sign shows that it's traveling downwards. So the negative sign implies it's traveling downwards. Right, so the sign of the displacement shows where it is with reference to the ground, which is our starting position in this case, and the sign of the velocity shows that where it's traveling at a certain instant in time. Let's add a part D, which is the maximum height reached, an examiner favorite in both the MCQs and in the structured questions. So for the maximum height, we again have the same initial measurements, the same initial values of the variables. So U is still positive 20, A is still negative 9.81. And the idea is that whenever you are asked the maximum height, you take the final velocity to be 0. And the reason for this is very simple. We can actually just see this by contradiction. So if it goes to some maximum height, if it had some more velocity at this point, it would have gone a little bit higher. But if it's not going any more higher, if this is the maximum height which it reaches, then that means that the velocity at this maximum height must be 0. Pretty easy to understand. So V is 0 and I need to find the maximum height, so I really need S. So now this time I'll be using V square equals U square plus 2AS. Keeping in mind the variables that I have, so I had U, A and V and wanted to find S. So this equation of motion involves all those four. So V is 0, U is 20 squared, 2 times negative 9.81 and then S. So S turns out to be positive 20 meters. Right, so this is the maximum height above the ground it has. The next part, let's add a part E as well, which is the total time of flight. For what time is it in the air? So here as well, there's a certain aspect of symmetry. Let's go to the diagram for this. So we know that when this is thrown upwards, at some point it's going to reach its maximum height. Right? This is the point where it reaches the maximum height and then it comes back down. So the idea is that whatever time it takes to go from here till the maximum height is also the time that it takes to go from the maximum height back again down to the ground. Right? So these times are equal. So I just work for the maximum height. So if I can find the time it takes for me to reach the maximum height, then I can just multiply that answer by 2 to get all of this time. Right? So let's go ahead and do that. So for the total time of flight, again, U is still positive 20 and we have A as well. And now we know, actually for the maximum height, we took V to be 0. And now we also know S equals plus 20. So for calculating T, we can again use any equation we want. Let's go with the easiest one, V equals U plus AT. So if V is 0, U is positive 20, A is negative 9.81. So the time for the for it to reach the maximum height, this turns out to be 2.039. So 2.04 if I take this to 3SF for now. So this value will also start to make a lot more sense now. If I look at it alongside the other parts that I did. So it takes it a time of 2.04, almost 2 seconds to reach the maximum height. So I know that when I was calculating the velocity of the ball before that time, at a time like 0.8 seconds, it was still moving upwards. And when I calculated the velocity of the ball at 3 seconds in, I think, part C, that was basically the latter part of the journey. At that time it was coming back down from the maximum height, so the velocity was negative, showing that it's traveling downwards. Right? So there's also this aspect that you can see. Again, it's a pretty commonsensical question, and things will be a lot more fun for you if you try to understand the physical significance of these quantities as well. So now that we know T equals 2.4, we know the total time of flight. If we call that a capital T, that would be twice of small t, so 2 times 2.04, this is going to be 4.08 seconds. Let's add another part f, which is the times, or actually the time for which the displacement, or let's just call it the height, for which the height is greater than, for which the height is 10 meters. Let's do this one first. So here you'll actually notice a very interesting thing, and actually let me make an adjustment to this. The times for which the height is 10 meters. So actually, if you think about it, we knew that the maximum height was 20, right? This is what we found in an earlier part. So halfway here, the height is going to be 10 at two different times. One would be when the ball is going up, so that would be this time, and another one when the ball is coming back down. So we'll actually have 2 times where the height is 10 meters, right? So we know this for a fact, but the equation will also work out in a way to show us this. So u is again positive 20, a is again negative 9.81, s is 10, right? Positive 10 because this is upwards from the ground, and we need to find out the time. So s equals ut plus half at square. So this is 10 equals 20t plus half of a, which is negative 9.81 t square. So this becomes negative 4. So let's first keep it like this. So 10 equals 20t, and this becomes negative 4.905 t square. So taking everything on one side, this becomes 4.905 t square minus 20t plus 10 equals 0. And if you just go ahead and solve this quadratic equation in your calculator, the times turn out to be 0.584 and 3.49 seconds, right? So we also knew what was the time for it to reach the maximum height. So actually first let's talk about this. We know that the earlier time must be the one where it's going up towards the maximum height, and then the other one is 3.49. And another really cool thing is this, that both of these times are actually symmetric about the time for it to reach the maximum height. So we saw that this time was t equals 2.04, I think, and this one just right now turned out to be like 0.58. So can I say 0.6? And let's also keep the one above S2, and then this one turned out to be like 3.5, right? So also there's a certain sort of a symmetry here in the times, that it takes basically it takes 1.5 seconds. This time interval from the maximum height to when it passes this is also 1.5 seconds, and then this time interval is also approximately 1.5 seconds. Why this is turning out to be 1.4 is basically just because of the approximation, but by the way, they are exact values, right? Let's add one last part, which is part G to this, which is if I ask you the times, or actually the time for which the height is greater than 10 meters. So what we saw was this, that this was the level ground, this was the object which was thrown up, so it went and came back down like this, and we saw that at this time 0.584 and this time 3.49. So between these times, this 0.584 and then this time, the height was less than 10 meters. So how can we find this time interval, right? So if this is where time equals 3.49, if this is where time equals 0.584, so everywhere in between the height is greater than 10 because it's above this 10 meter level. So then this time, which is really the time difference, is going to be 3.49 minus 0.584, and this will turn out to be 2.9 seconds. So this is a full question which covers all the types of questions which can be asked in your exam.